Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. So in this video we are going to continue to solve combination problem. So let's look at example 6. In a mathematics examination, students will be given 8 questions. Students have to answer only 5 questions. Find how many ways the student may choose their question for A, without any restriction. For B, question 2 and 4 are compulsory, and for question C, if question 5 is chosen, then question 6 should be ignored. So we are going to solve A first. So without any restriction, choosing 5 out of 8 questions, we are going to use this formula, C5. Okay, so press your calculator to get the exact value. So XC5 is equals to 56. Okay, 56 ways to choose 5 questions out of 8 questions without any restriction. And now let's look at B. Question 2 and 4 are compulsory. Okay, so question 2 are compulsory, so I'm going to put 1C1 for question 2. And then question 4 is also compulsory, so we have to choose question 4, so 1C1 also. And then we already chosen 2 questions. We need to choose another 3 questions to make it 5 out of 6 more. Okay, out of 6 more questions. Okay, and then we are going to multiply everything. 1C1 we are going to get 1. Okay, multiply by 1, and 6C3 is 20, so the final answer is 20. And now let's look at question C. If question 5 is chosen, then question 6 cannot be chosen. Okay, so we are going to look at 2 cases here. The first case, if we choose question 5, question 5 is chosen here. Okay, so 1C1 for question 5 is chosen, but if we choose question 5, okay, we cannot choose question 6 automatically. Okay, so we only have 6 more questions. 1, 2, 3, 4, 5, 6. Okay, 6 more questions, and to choose another 4 because we need 5 questions. Okay, or if question 5 is not chosen, I'm going to delete question 5. So we have 7 choices, and then we need to choose 5. Okay, so the answer is 21. Okay, and then the number of ways we have to add the 2 values. So 15 plus with 21. Okay, 15 is from this case. Okay, so when we add those 2 numbers, we are going to get 36. Now let's move on to example 7. In a football training squad of 24 people, 3 are goalkeepers. Okay, so 3 are goalkeepers, 7 are defenders, 6 are midfielders, 8 are forwards. Okay, so a final squad of 16 selected for a match must consist of 2 goalkeepers, 4 defenders, 5 midfielder, 5 forwards. I can find the number of possible selection if 1 particular goalkeeper and 2 particular defenders, 3 particular midfielder and 3 particular forwards are automatically selected. Okay, so it will be useful if we list down all the information given. Okay, so for goalkeeper, we have the position of goalkeeper, we have defenders, we have midfielder, and we have forwards. Okay, so for goalkeeper we have 3 goalkeepers. Okay, for defender we have 7 defenders. For midfielder we have 6, and for forward we have 8. Okay, so we need for final squad we need 2 goalkeepers, so we need 2 goalkeeper here, and then we need 4 defenders. Next we need 5 midfielder, and then we need 5 forwards. Okay, but there is one particular goalkeeper automatically selected. So for goalkeeper, we have one which will be particularly selected. Okay, so we put there 1C1. Okay, for defenders we have 2. Okay, so we put 2C2. And then for midfielder, 3 particular midfielder, so 3C3. And then for forward, we have 3 particular forward, 3C3. Okay, so I'm going to find how many ways can we form the team. Okay, so for goalkeeper, this 1C1 is for the one that will be particularly selected. Okay, and then we know that for goalkeeper, we have 3 goalkeeper. Okay, but we need 2. Okay, but one is already particularly selected. Okay, so out of 2 we choose another one. Okay, so the result is we get 2 goalkeeper. Okay, for defender, we have 2 particular defender. Okay, 2C2. Okay, and then altogether we have 7 defenders, and now we are left with 5. Okay, and we need to choose another 2 defenders. Okay, because we need 4 defenders. So we need 4 defenders. So here is actually 4. Okay. Okay, for midfielder we need 3. Okay. Okay, for defenders we know that 2 particular defenders is automatically selected. So it is this one. And then for defender we know we have 7 defenders. Okay, so 2 is already particularly selected, so we are left with 5 to select for another 2 because we need 4 defenders. Okay, so multiplying 2C2 times 5C2, we are going to get 10. And then we are going to repeat the same process for midfielder. Okay, and then we are going to multiply because this is not or, this is and. Okay, choose goalkeeper and defenders and midfielders and forward, so we have to multiply instead of adding. Okay, so the answer is 600. Okay, and then we are going to look at how to distinguish between permutation or combination. So very often students are confused with concepts of permutation and combinations. Okay, so the most important thing or the easiest way to memorize is for permutation, position is important, but for combination, position is not important. It is only the method of choosing. Okay, so let's look at a question. 15 glasses of similar color and size, each number from 1 to 15. In how many ways can 8 glasses be selected? Okay, so the keyword here is select, so that 5 have odd numbers and the rest have even numbers. And for question B, 5 glasses be arranged in a row so that the first 3 glasses have odd numbers and the remaining 2 have even numbers. Okay, so those glasses, 15 glasses, are numbered from number 1 to number 15. So we have how many odd numbers and how many even numbers from 1 to 15. We have to consider that. Okay, so I'm going to list it. So we have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So I'm going to color the odd number with this green highlight. Okay, so this is odd number. These are odd numbers. Okay, and the one that I don't highlight is the even numbers. Okay, so we have how many odd number? Okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so we have 8 odd numbers, and for even number we have 1, 2, 3, 4, 5, 6 and 7. So we have 7 even number. Okay, so the question states that 8 glasses to be selected, that 5 have odd numbers and the rest have even numbers. Okay, so we want 5 to have odd numbers. Okay, so we have 8 odd numbers, so we are going to choose 5. Okay, and from even number we just need 3 glasses. Okay, so the answer will be 1960. Okay, and then for question B, 5 glasses be arranged. Okay, arrange is an important keyword here, so that the first 3 glasses have odd numbers and the remaining 2 have even numbers. Okay, so this is permutation, so I'm going to use P. So we have egg P3. Okay, out of 8 odd numbers, we are going to arrange 3 and then multiply with 7P2, so the answer will be 14,112. So now let's move on to example 9. Given the word January, find the number of ways to arrange 3 letters from the word January. And for B, find the number of ways to select 3 letters from the word January. So obviously question A is about permutation, and question B is about combination, because looking at the keyword, okay, the keyword here is arrange and the keyword here is select. So we are going to start with question A first. Arrangement with 2 letters A. We want to choose 3 letters from January. So if 2 letters A are chosen, that means there will be 2 identical A. So from 3 letters, I'm going to have to divide with the 2 identical A. Okay, and then another one, okay, is any letter. It can be either J, it can be either N, U, R, or Y. So we have 5 choices here. That's why I'm going to multiply with 5. Okay, so the answer is 15. And then for arrangement with 1 letter A or without A, I'm going to take out 1A. Okay, so what's left is we have 6P3. Okay, arrange 3, so the answer is 120. So adding up, the answer will be 135. And now let's look at question B. Selection with 2 letters A. Okay, that means that 2 letter A must be automatically selected. So 2C2. And then another one, we are going to choose from the other 5 letters. So we have J, 1, 2, 3, 4, and 5. Okay, so it is 5C1 here. So the answer is 5. Okay, and a selection with 1 letter A or without A, I'm going to take out 1A. So we have 6C3. So the answer will be 20. So adding up, we will get 25.